This set of challenges contains some brain-teasing logic puzzles and riddles. I'll explain each problem, then there will be a point where you can pause and think about the answer if you want to before seeing the solution. So let's get started now. A group of 10 people are sitting in a line. Each person says the person to my right is lying, except the rightmost person who says everyone is lying except me. How many people are telling the truth? The solution to this problem is that there must be 5 people telling the truth. Well done if you got that right. If not, you might want to pause and think again before watching the rest of the solution. Let's call the people numbers 1 to 10 from left to right. Suppose person number 10, the person on the far right, is telling the truth. Then the person to their left, person number 9, says that person 10 is lying, but that wouldn't be true, so person 9 would be lying. Then person 8 says that person 9 is lying, which would be true, so person 8 would be telling the truth. Now person 10 says that everyone is lying except them, so that would be a lie, but we started by assuming person 10 was telling the truth, so this has created a logical contradiction, so this version of events can't be correct. On the other hand, suppose person 10 is lying. Then person 9 says that person 10 is lying, and so they would be telling the truth. Person 8 says that person 9 is lying, which is false, so person 8 is lying. Person 7 says person 8 is lying, so they're telling the truth. Continuing in this way, we find that all of the odd-numbered people, 1, 3, 5, 7 and 9, are telling the truth, and all the even-numbered people, 2, 4, 6, 8 and 10, are lying, which this time is consistent with the fact that person 10's statement is a lie. So that's the answer. There are 5 people telling the truth. You see these 4 cards laid out on a table. Each card has a letter on one side and a number on the other side. Your friend tells you they think every card with a consonant on one side has an even number on the other side. Which cards do you need to turn over to determine for sure whether they are correct? The answer to this problem is that we must turn over the cards with the B and the 3. If you've got something else, you might like to pause and think again before we go through the solution. Let's consider the cards one at a time. The easiest to think about is the B. This is a consonant, so you definitely need to turn it over, because if you see an odd number, you'll know your friend is wrong. Next, let's think about the E. This is a vowel, and our friend's statement is only about cards with consonants, so we don't need to turn that one over. So far, not too bad, but the mistake people make with this question is to think that it's necessary to turn over the card with the 8. In fact, this is not needed, because it doesn't matter what's on the other side. If it's a consonant, then that's consistent with your friend's statement. If it's a vowel, then, like the card with the E, it doesn't matter what's on the other side. So we don't need to see what's on the other side of this card. You do, however, need to turn over the card with the 3. If there's a vowel on the other side, that would be consistent with your friend's statement. But if there's a consonant, then there would be a card with a consonant on one side and an odd number on the other, contradicting your friend's statement. So the 2 cards we need to turn over are the B and the 3. A £20 note is contained in one of 3 envelopes. Envelope 1 reads, the £20 note is not in this envelope. Envelope 2 reads, there is a £20 note in this envelope. Envelope 3 reads, 1 is an even number. If only one of the statements is true, which envelope contains the £20 note? The £20 note must be in envelope 3. Feel free to have another go before watching the solution if you got something else. Suppose the £20 note is in envelope 1. Then the statement on envelope 1 would be false. The statement on envelope 2 is false too because the £20 note is not in envelope 2. The statement on envelope 3 is always false, and so all 3 statements are false. We know that exactly one of the statements is true, so the £20 note can't be in envelope 1. Now suppose the £20 note is in envelope 2. Then the statement on envelope 2 is true, but the statement on envelope 1 is also true because the £20 note is not in envelope 1. But only one statement can be true, so the £20 note can't be in envelope 2. Hence, the £20 note must be in envelope 3. In this case, the statement on envelope 1 is true because the £20 note is not in envelope 1, the statement on envelope 2 is false because the £20 note is not in that envelope, and the statement on envelope 3 is always false. So this is consistent with one statement being true, and it must be that that £20 note is in envelope 3. Alex, James and Bill are 3 friends of different heights. Alex, who is 12 years old, says James is taller than Bill. Bill, who is 13 years old, says he is taller than James. James, who is only 11 years old but is not the shortest in the group, says that he is taller than Alex. If only one of the 3 friends are correct, what is the order of the friends from tallest to shortest? The solution is that Alex is the tallest, James is in the middle, and Bill is the shortest. Feel free to have another go if you want to. Firstly, we notice that the ages of the friends are irrelevant, and are included only as a distraction. Since Alex and Bill's statements are direct opposites, Alex says James is taller than Bill, but Bill says he is in fact taller than James, then exactly one of them must be correct. Since we know that only one of the friends is correct, and that one of Alex and Bill are correct, then we know that James's statement must be incorrect. So that means that Alex is taller than James, but we know that James is not the shortest in the group, so James must be taller than Bill. Hence the order from tallest to shortest is Alex, James, Bill, and Alex's statement is the one that's correct. 4 people are playing a party game where they will either all win a prize or everyone will get nothing. 3 of the players sit in a line facing a wall. A is closest to the wall, B is behind A, and C is behind B, like this. D is on the other side of the wall. They are given party hats and told that there are 2 red hats and 2 blue hats, but they don't know who has which hat. Each of persons A, B, and C can see only the hats in front of them, but neither their own hat nor any behind them. D can't see or be seen by any other person. If any person can definitively determine the colour of the hat they're wearing without guessing and then announce it, they will all win a prize, otherwise they all get nothing. If we assume that all of the participants are totally rational, want to win the prize, and they also know that all of the other players are also rational and want to win the prize, is it possible for the players to be certain that one can correctly announce their hat colour so that all of them will win the prize? It is possible. The players know that there are only 2 hats of each colour. So if C observes that A and B have hats of the same colour, C would deduce that their own hat is the opposite colour. However, if A and B have hats of different colours, then C can say nothing. So the key to their success is that player B can pause for a while, knowing that C would speak promptly if they did know their own hat colour. If C is silent, B can infer that the hats on A and B must be different. B can see A's hat, so if it's blue, they know their own hat is red, and if they see A's hat is red, then they know their own is blue. There is no other winning strategy, so the other players know to stay silent and it's guaranteed that they will win the game.